Good morning. Today we want to see about numericals which we have to solve by using Kirchhoff current law, Kirchhoff voltage law. Then we can use source transformation in the power. Then we can use Thevenin Norton superposition theorem to calculate the values of voltage and current. We are taking our today's extra lecture because you guys are requested to solve the numericals. So on your demand, we will study about numericals, how to solve in by using the KCL, KVL, Thevenin's theorem. We'll wait for other students for 1 minute. Then we can start our today's session. So we can start our today's session. So in this unit, we have to study about Kirchhoff current law and Kirchhoff voltage law. Before that, we will see about what is meant by voltage, what is meant by current, what is meant by power, these things. So you guys are aware about current, voltage, power. So firstly, if we see Kirchhoff voltage law and Kirchhoff current law, we are using these laws because these are two basic electrical laws that can be used to analyze given network when network is complex containing many loops. It means what? If any
WhatsApp.
Shivputra, please mute yourself. Okay. So what we are saying, by using Kirchhoff current law and Kirchhoff voltage law, we can solve complex circuit which is having lots of loop, which is having lots of nodes. So we can use node analysis method to solve our loop. Okay. To solve our loop and to solve the node analysis method. So we firstly see about the charge, because we know each atom will consist of the nucleus which is having the positive charge and it will be surrounded by the negatively charged particle. We are calling that particle as a electron. So charge can neither be created nor be destroyed, it only be transformed. मतलब हम उसे सिर्फ ट्रांसफॉर्म कर सकते हैं, we cannot create or we cannot destroy that charge. So we are calling that charge as a law of conservation of charge because we cannot destroy that charge. It will only transfer to other. And if you see, the SI unit for charge is a coulomb, and we can denote charge in electrical circuit language by letter Q. So if you see, electrical current is directly proportional with the charge. How? Because we know if there is a movement of charge, at that time we are saying electrical current is produced. So SI unit of current will be ampere, and we can denote current by letter I. And if you see, mathematically we can write current equal to derivative of charge with respect to time. It means what? dq of t upon dt. We can write. Then we are supposed to study about the voltage. So what does mean by voltage? We can call voltage as battery, we can call voltage as power supply, or we can call voltage is nothing but it is a potential difference between 2 points. Is the work in joules required to move 1 coulomb of charge from one point to the other point. It means what? We can call voltage as a potential difference also. And if you see, for the SI unit, for the voltage, we can measure voltage by using volt. So we can say volt is the unit for the voltage. Then we can see we are using the power also. So what is meant by power? Power is nothing but it is the rate at which energy get transferred. So in electrical circuit, in terms of current and voltage, we can calculate power equal to V into I. And if you are saying it is the rate of energy with respect to time, so we can calculate P equal to dW upon dt, or we can calculate P equal to V into I. Now we can see about the Kirchhoff current law, because this law, Kirchhoff current law, is used to find the value of current flowing through node, because Kirchhoff current law states that at any node incoming current is equal to the outgoing current, or we can say algebraic summation of current at any node will be zero. And if we are taking incoming current as a, if you see here, if we are having one circuit, here the batteries are given, we are having the batteries, we are having the node, they have given the node's name. So what we are supposed to use here, we are supposed to use the Kirchhoff current law and Kirchhoff voltage law. So Kirchhoff current law क्या बोलता है हमें, Kirchhoff current law states that at any node incoming current is equal to the outgoing. So if you see here, there are 5 nodes, so we will get the 5 equations and we can equate that linear equations, so we will get the values for I1, I2, I3, I4, I5 and I6. How will you get if you are calculating for node B? Just I am taking one example. If we are having this circuit and we are calculating current flowing through this node B. So if you see, if we are giving here clockwise direction for current, here also. So we will take here positive, negative directions, positive, negative. So if you see here, we are giving this as a directions in clockwise. It means what? It is incoming to the P. If you see for I6, it will go from point B. So we can say this is the outgoing current. If you call for I4, you can see it is also outgoing. So according to the Kirchhoff current law, we are saying incoming current at any node is equal to the outgoing current at that node. So our equation will become I3 equal to, because it is incoming, equal to outgoing. Outgoing, if you see I4 and the I6. So our equation will become I4 plus I6. So you will get I3 equal to I4 plus I6. So here, if you are saying again in the Kirchhoff current law in another language, what we are saying, Kirchhoff current law states that algebraic summation of the current at any node will be zero. So we are saying that current as a Kirchhoff current and that will be zero at each node. If we are taking algebraic summation, how will you take? As it is incoming, if you are taking positive, so I4 and I6 को हम नेगेटिव लेंगे, तो हमारा इक्वेशन क्या हो जाएगा? I3 minus I4 minus I6 equal to 0. Both are having the same meaning in the math term. You can say I3 equal to I4 plus I6, or you can say I3 minus I4 minus I6 will be equal to 0. So now what we are saying, if we are applying KVL at node B, we will get this equation. If we are taking I3 as negative, so what will become? I4 and I6 positive हो जाएगा. So our equation will become minus I3 plus I4 plus I6 equal to 0. So according to Kirchhoff current law, incoming current as equal to the outgoing current, or we can say the current summation of the current at any node will be 0. And we are following the sign conventions, because if current will leave the node, we are taking the positive, and if current is coming, we are taking it is negative. Again, you can say here, if we are applying Kirchhoff voltage law, so what we are saying, Kirchhoff voltage law states that algebraic summation of potential drop or a voltage across each and every element for closed loop will be 0. So what does mean by loop? Can anyone answer my question? Kamla, are you there? What we are saying, the voltage potential drop across each and every element, if we are taking the summation of that voltage, that will be 0 for closed loop. And closed loop is nothing but a loop. We are saying if the incoming current, the current flowing from any point will have return path to come return, at that time we are saying that as a closed loop. You can see here, this is also a closed loop, and this is also a closed loop. So if current is flowing I4, it will again go to that point B. मतलब B से start हो रहा है, point B से B तक फिर से जा रहा है. So we are saying that as a Kirchhoff, that as a loop. So now we are supposed to study about the Kirchhoff voltage law. If we are applying Kirchhoff voltage law to our first loop, first loop is nothing but A, B, D, E. You can see here. Our first loop is A, B, D, E, and if you are applying KVL, KVL क्या बोलता है? Algebraic summation of the potential drop for every element across closed loop will be 0. So if you see here in this, if you are starting from this point A, B, D, E, तो A से start कर रहे हो. So if you are taking here sign convention, if you are taking potential drop as a positive, तो potential rise को तुम क्या लोगे? Negative. So if we are having here positive negative directions, so we are saying it is the voltage drop. So we are taking here V3 positive. Again, if you see V6 also positive to negative. If you are taking clockwise direction, I have shown here the clockwise direction. You can see. So I am again taking V6 as a positive. So now for voltage which is flowing across R1, you can see here it is first negative then positive. So we are supposed to take minus V1. Again, if you are see for the V2 which is voltage across this point, if you are taking here it is negative direction, it is positive, and you are taking the clockwise. That's why again you are supposed to take minus V2. So your equation will become V3 plus V6 minus V1 minus V2 equal to 0. Or in another language you can say about the Kirchhoff voltage law like potential rise across a branch equal to potential drop across a branch. If you are taking potential rise V1 V2, so your equation will become V1 plus V2 equal to potential drop जो है V3 and V6, because if you see here it is first positive then negative. So your equation will become V1 plus V2 equal to V3 plus V6. Both are having the same meaning. You can explain Kirchhoff voltage law in any language. Algebraic summation across each element for closed loop will be 0 if you are solving like this. And if you are saying potential drop across each branch equal to potential rise across each branch, you can write like V3 plus V6 equal to V1 plus V2. So now we are saying we are having the independent and dependent energy sources. So again, if you see in independent and dependent, we are having two types: voltage source, current source. And in dependent, we are having the four types. How values are depend on the other values. So firstly, we will see about the independent voltage and current source. We are calling this voltage and current source as the energy source because these terms are giving us energy. So independent energy source is a voltage or a current whose value does not depend upon any other voltage or current or the circuit to which the circuits are connected. If you are connecting that voltage source or current source to any other circuit, but the values of voltage and current are not dependent on any other, these are independent. At that time, we are saying this voltage source and current source as the independent. Like we are saying, now we are independent, we guys are earning like this. If these are not depending on any other, we are saying these are the independent. Now we can see about the dependent. So dependent means what? The dependent energy source means what? That will be voltage or that will be current. So dependent energy source is a voltage or current energy source whose value depend upon some other voltage or current, and depending on how it will depend, there are four types of the dependent energy sources. This is the voltage, current, voltage source. It means what? If you see voltage controlled voltage source, it means voltage का जो value है, it will be depend on the voltage. You can say voltage controlled current source. Like this, C is nothing but we are denoting C for the controlling voltage or the controlling current, and you will get the equations here. If that voltage is not depend on any other, that voltage will remain same. So V of t equal to जो दिया है supply voltage Vs of t. Current, if this is independent, you will get the same current. If this is dependent on voltage, you will get voltage equation which will be dependent on voltage, and we are saying that alpha is nothing but it is the constant. We are taking here voltage will be depend on given voltage. So we are saying that voltage as a controlled voltage. Here, if value of current is depend on the voltage, like this, we will get different types of the dependent energy sources. So here, you can see here, what we are saying, we are supposed to calculate the power. So instantaneous power absorbed by an element will be equal to if we are having any circuit in which there are lots of current and incoming, so we can take P of t equal to V1 of t into I1 of t plus V2 of t, I2 of t up to Vn of t into In of t. It means what? This will measure the values of power. Now you can see here, if we are having the two terminal element, you can see here, if we are having this resistance, here is voltage V1 across this node, and at this node, if voltage is V2, if we are taking, so our equation will become P equal to V1 I1 plus V2 I2. And if you see this current is potential drop, but it is a potential rise. So you can take this direction as a minus I1, because both are having the same value of current, because this is the same element. And if we know, if element is same or two elements are connected in series, at that time current value will remain constant. So you can convert that equation in the form of I1. You will get V1 I1 plus V2 into minus I1, because it is having only the negative directions. So you can convert this equation in the form of V1 minus V2 into I1, and V1 minus V2 is nothing but here it is the potential difference for these two terminals, or we can say it is the voltage. So you will get our equation P equal to V1 minus V2 into I1. Now, what we are doing here, you can see here, I am writing the same diagram, I am writing the same equations here for two terminals. Now, if we are having any device which is having the three terminal, like if we are taking the BJT, you can see here we are taking the BJT which is having three terminals. We are taking the voltage across collector as VC, voltage across base will be VB. We are taking current flowing through emitter as IE, and voltage that will be VE. So if you are calculating here power, you will get equation. You can see here VC is here incoming, VB is incoming, and VE is outgoing. So you can take here VB IB plus VC IC minus VE IE. Again, we know IE is nothing but IB plus IC. So we can write IE in the form of IB plus IC. If you solve this equation, rearrange these equations, you will get power across this three terminal BJT will be VBE plus IB plus VCE IE. I am showing you how we will get these equations, because in electronic circuit you guys are supposed to solve for the hybrid model in our first and second equations, in our first and second unit, MOSFET analysis, We have seen there we are using the single stage C amplifier and all these things. At that time you will be required how to solve, how to apply KVL. That's why I am showing you how you can write this equation. You will be needed for MOSFET. I am showing here for the BJT. So if you are calculating here power, you will get VBE into IB plus VCE I. So a resistor can only absorb power since V and I have the same sign. So if we are making the power greater than 0, at that time we can say energy absorbed by resistor goes in heating and the rest of world. Often we are using the heat sink because there is a, if there is a larger amount of heat get produced. अभी किसने ज्वाइन किया क्लास? योगिता या विशाल? Okay, leave it. So we are using heat sink that will be used to dissipate the thermal energy, and the temperature will does not become high. It will dissipate that increased amount of heat. So we are using the heat sink. Again, if you see a source, we can say like a DC voltage source can absorb or can deliver the power. It will means it can take or it can give power since the sign of voltage and current are independent. So if we are taking one example, you can say if battery is charged, it will absorb the energy which gets stored within it. A capacitor can absorb or deliver power. When it is absorbing power, its charge build up. Similarly, we know inductor also can store energy in the form of magnetic flux, but capacitor can store energy in the form of charge. और inductor क्या करता है? In the terms of magnetic flux. So if we are having the resistor in series, how we can calculate total resistance? We are taking only simply additions, R1 plus R2 plus R3. And if you see, if resistors are connected in series, at that time value of current flowing through each resistance will be same, but voltage will get divided. This is the total voltage, so voltage will get divided across R1, R2 and R3. So you will get here voltage equations for R1, R2 and R3 like this. V1 equal to IR1, V2 equal to IR2, V3 equal to IR3. And you will get total voltage equal to V1 plus V2 plus V3, or you can rewrite these equations because we know I will be same. So we can take I as a common and in bracket R1 plus R2 plus R3. So we can calculate here equivalent resistance, that will be the addition of all these three resistors. I will provide these PPTs also to you so you guys can practice at your home. After finishing our today's this lecture, there will be again lecture on 12 o'clock. You all are supposed to join that class. So if we are calculating here the value of voltage drop across RK, that will be V into RK upon R equivalent. We are taking if that value as RK. If you see here, if we are having this resistance, three resistance in parallel, we know if the two or more elements are connected in parallel, voltage across each element will be same, but current gets divided. So here we can calculate value of current as 1 by R1, resistance का reciprocal, we can call as a transmittance. So I am taking here G1 for 1 by R1, reciprocal of R1. So if you are calculating the values of current, because these resistors are connected in parallel, obviously current flowing through each and every element will be different. That will be not same. So we can write as I1 equal to, we can write V by R1, or you can write G1 into V, because 1 by R1 we are saying as a G1. So you will get total amount of current I equal to I1 plus I2 plus I3, but we aware about. If these resistors are connected in parallel, voltage will be same. So you can take voltage as a constant and you can write in bracket 1 by R1 plus 1 by R2 plus 1 by R3. Or you can write G1 plus G2 plus G3 into V. So here if you are calculating total resistance, you will get 1 upon R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. And if you are calculating in the form of conductors, you can say G equivalent equal to G1 plus G2 plus G3. And accordingly, you can solve for resistance that will be the reciprocal of that G equivalent, this trans conductance. You can see here. If we are calculating here trans conductance, if we are having two resistors, you can calculate R equivalent equal to R1 R2 upon R1 plus R2. If we are having three resistors, you can calculate R1 into R2 into R3 upon R1 plus R2 plus R3. Or if you are solving values of current where we are having two resistors, at that time you can solve I1 equal to total current into the current flowing across the resistance that will be in parallel. So you can take here, if तुम R1 के वहाँ का current निकाल रहे हो तो according to by using the current divider rule you can take total current into the resistor that will be across or in series another resistor R2 upon the total resistor R1 plus R2. This is we are saying as a current divider rule. If we are having this circuit, if we are supposed to calculate the values of resistor, how we can calculate? You can see here 4 ohm, 6 ohm, 6 volt and 3 ohm. I am writing as it is. And you can see these three resistors are in parallel. A 2 ohm, 3 ohm you can write as it is. And if these are in parallel, you can calculate 1 upon 2.5, 1 upon 2.5 plus 1 upon 5, that will be equal to 1 upon R equivalent. So you will get R equivalent equal to 2.5 into 2.5 into 5 upon 2.5 plus 2.5 plus 5. That will have equal to value 1 ohm. So you can write here equivalent resistor for these three resistors, that will be 1 ohm. These things will be needed in superposition, Norton's, Thevenin, all these theorems. That's why we are practicing how to solve equivalent resistors. Because Thevenin equivalent resistor तुमको derive करना है, तब तुम्हें समझना है कि रेजिस्टर पैरेलल में है तो हम कैसे कैलकुलेट कर रहे हैं, रेजिस्टर सीरीज में है तो हम कैसे कैलकुलेट कर रहे हैं. Now again, if you see here, how we can see here this 2 ohm, sorry, now we can see here this 2 ohm, 3 ohm and 1 ohm are in series because these are connected by 1 by 1. There will be no node. So we can take 2 plus 1 plus 3, that will be as a 6 ohm. Now again you can see these two are in parallel because both are having the common node. So again you can calculate 1 by 3 plus 1 by 6 equal to 1 by R equivalent, that you will get 1 by 2. So R equivalent will be 2 ohm. So you can write here 6 volt 4 ohm as it is and you will get here 2 ohm. So here you will get here now very smaller circuit. And if you are using the current divider rule, no, if you are not using here current divider, only you are supposed to calculate the values of current flowing through these two. And we know these are in series. The value of current flowing through these two resistors will be same. So you can directly use Ohm's law. V upon R equal to I. So V क्या दिया है यहाँ पे 6 वोल्ट दिया है. So you can take 6 volt. और resistor दोनों series में है. So you can take 6 volt upon 4 ohm plus 2 ohm. That will be 6 upon 6. So you will get 1. And we are using unit for current as the ampere. If you are supposed to calculate the values of current I2 for this circuit, you can see here. Now your circuit is this. You are supposed to find the values of current I2. How will you find? By using the current divider rule. So we know we are supposed to find the value of current flowing through this I2. So you can see here, if you are finding the value of current this I2, you are aware about I1, so that will be total current you can take into that resistance that will be in parallel. So you can take 6 and total resistance 6 plus 3. So you will get 6 upon 6 plus 3, that will be 6 upon 9. You can write 2 by 3 and we are having the unit ampere. So you will get the values of current for this complicated circuit by using how to find equivalent resistance, how to use Ohm's law, and how to use current divider rule. Now your homework is verify KCL and KVL that are satisfied for each node and each loop. You are supposed to find KCL for each node, like for this node, for this node, for this node, for this node. You are supposed to verify KCL law is satisfied or not, and you are supposed to use KVL also. Verify total power absorbed by resistor that will be equal to power given by supplied source. You are supposed to verify that power also. Now, if we are having one circuit, so we are supposed to use here node analysis. So node analysis क्या बोलता है? Node analysis is saying if we are having the node. So what is mean by node? If we are having the any point in the electrical circuit at which if two or more elements are connected, you can see here, if we see here also three elements are connected. If you see here also three elements are connected, it means what? The point in the electrical circuit which is having two or more than two elements are connected, at that time we are saying that method as a node. We are saying that point as a node. So if we are supposed to use the node analysis, we can make the use of KCL. So we can say node analysis method as a KCL if we are having this circuit and we are supposed to use the node analysis. So we can see here, take some node as a reference voltage and we are supposed to denote remaining voltages as V1, V2 and V3. We are taking reference node as this node and we are calling the voltage across reference node will be 0 volt. And we are supposed to find the voltage across remaining node. How we can find? We can assign that node as the name V1, V2, V3 as we require. If we are assigning and we are taking here reference node voltage 0, we can apply KCL at each node in terms of node voltage, because here we are supposed to use node analysis. So we are using our sign conventions, like if current is leaving, we are taking its positive. So if we are applying here node analysis, we can take, you can see here, if we are applying here KCL in terms of voltage, because we are saying here we are supposed to apply KCL in terms of the node voltage. So if you see, we are supposed to find the value of current for this resistor. How will you find? Where current starts and where it is going, मतलब यहाँ से यहाँ जा रहा है. So you can take V1 minus V2 upon that resistor R. Again, if you are calculating here for this, we are taking this as a 0, so you can write as it is I0. If you are calculating for this node V3, we are aware about the value of resistor here, so you can take here V2 minus V3 upon 1 by R3. Like this, you can solve node analysis by using KCL. Solve for the node voltage, branch voltage, current. If we are having this circuit and we are supposed to use mesh analysis, but it will not finish. We are having only 3 minutes now. It's fine, we will see in next session. So here in node analysis, what we are saying here, if we are supposed to find the values of current by using values of voltage by using the KCL, because in node analysis we are using the KCL and we are finding the values of voltages. So you can write the equation in the form of voltage and resistor by using the KCL. So if you are writing for 1 by R1, it's nothing but if you are writing for that V2, from V2 if you are writing V1 के लिए तुमने क्या लिखा है, you can see here V1 नोड कहाँ कहाँ कनेक्ट है, यहाँ V1 से V2 को है, V1 से 0 को है, तो वो तो डायरेक्टली मैंने 0 ले लिया, and V1 is connected to 3 V3 also, so I have taken here minus K V2 minus V3 0. Now we are calculating for this V2. How we can calculate? You can see here V2 से तो हम V2 को पॉजिटिव लेंगे, V3 को निगेटिव, V2 को पॉजिटिव लेंगे, 0 को निगेटिव, V2 को पॉजिटिव लेंगे, V1 को निगेटिव. Like this, the node for which we are applying the KCL, we are supposed to start from that node and we are supposed to end with remaining node which we are having connected with that V2. So V2 kaha connected hai? V1 ko. So you can take V2 minus V1 upon R1 as a positive. Again, if you are calculating for this R3, you can take V2 minus V3 plus R3. That will be again positive. Again, you can take V2 minus 0 upon R2. So I have directly written here V2 upon R2. That summation will be 0. और यहाँ पे मैंने negative sign क्यों लिया है? You can see here for V1 minus V2 R1, I have taken positive. Sorry. But why I have taken here negative? I have taken here the negative sign. Why? Because you can see I0 का symbol जो है डायरेक्शन कैसा है, यहाँ पे इनकमिंग है, इट इज नॉट आउटगोइंग एंड वी आर टेकिंग leaving node as a positive. That's why I have written here minus I0, but its value is 0, so there will be no difference. Again, if you see V1 यहाँ से V3 तक ड्रॉ करना है हमें, because it is connected with this point. But again I am taking here negative. Why? Because it is also having incoming direction. Just because of this reason I have taken here minus. And you are supposed to calculate like V2 minus V3. You will get this value. Again, if you are solving for V3, you can see here V3 is connected with this, V3 is connected this R4. So you will get equation K V2 minus V3 plus V3 minus V2 upon R3 plus V3 by R4 equal to 0. So here we have finished about node analysis. You guys are supposed to join class on 12 o'clock. We will see about Mesh-Thevenin theorem there. Okay, thank you. You guys can leave now. I am taking your attendance. Okay, you guys can leave now. Thank you. 15 मिनट का ब्रेक है, फिर से ज्वाइन करना है क्लास.